ready to go. Hello, everyone. Hello. Visual Studio Live. It's great to have you here on campus again. Welcome. Thank you all for being here. I'm Daniel Roth. I'm the product manager on the ASP.NET team for Blazor. And today we're going to talk about all of the new features and capabilities that are coming in Blazor in .NET 8. Blazor is a powerful web UI framework based on .NET. With Blazor, you can build beautiful and richly interactive web experiences using .NET and C#, no JavaScript required. Combined with an ASP.NET Core backend, Blazor and ASP.NET Core enable full stack web development with .NET. Blazor comes with a powerful reusable component model that you can use to easily handle UI events, render updates, and set up two-way data bindings. Blazor comes with built-in components for handling forms and validation, as well as displaying large virtualized data sets. There are also lots of component libraries that are readily available from the community that you can just download and install as a NuGet package and use. You can build progressive web apps with Blazor so that you can make your web apps installable and support offline scenarios using the latest open web standards. We provide rich tooling for Blazor in Visual Studio and with Visual Studio Code, including support for hot reload. And while you write your Blazor apps typically using C#, if you want to, you can interoperate with JavaScript if you have existing JavaScript libraries that you'd like to reuse. Now, Blazor has actually been around for a little while now. Like it's I think it's over 5 years that we've been releasing Blazor releases. The first experimental releases of Blazor, I think, were in early 2018. And with each .NET release, it just keeps getting better. This past November, we just shipped .NET 7, which had lots of great new Blazor features. In case you missed it, here's just a recap of a few of the highlights. In .NET 7, we expanded Blazor's reach beyond the web. You can now use Blazor to build native mobile and desktop apps using the Blazor hybrid pattern that's integrated with .NET MAUI. We added support for building standards-based HTML custom elements with Blazor so that you can embed a Blazor component really in any application. We addressed a number of top feature requests like handling location-changing events, some improved data binding semantics, and more flexible handling of authentication requests. At the WebAssembly layer, we also did a bunch of investments. We added new capabilities like a new low-level JavaScript interop model, as well as support for the SIMD and exception handling WebAssembly standards. If you haven't already, I encourage you to go and try out Blazor in .NET 7 today. You just go to blazor.net, click Get Started, and go ahead and run through your first tutorial. If you haven't seen these new features from .NET 7, I encourage you to go check out Steve Sanderson's .NET Conf talk from last year. You can find that at aka.ms/Blazor in .NET 7. Of course, this talk isn't about .NET 7. We're here to talk about what's coming in .NET 8. What's the new stuff? So in .NET 8, we want to enable you to use Blazor to get the best of both the client and the server when building web UI. Modern web applications typically need to use a combination of approaches involving both the client and the server to deliver the best web UI experiences. Many web apps will dynamically generate HTML from the server in response to requests. This is typically called server-side rendering, or SSR. Server-side rendering is really nice because it helps your app load really fast. All the hard work got done on the server to load the data and decide what to render. And all the browser has to do is display the already rendered HTML. In .NET, we've always had great support for server-side rendering with frameworks like MVC and Razor Pages. Now, for rich interactivity, you generally want to handle things from the client. And for that, you use client-side rendering, or CSR. By rendering from the client, you can have really low latency UI interactions, and you can leverage client capabilities, like if you want to access local storage, or the camera, or local compute, and so on. For client-side rendering with .NET, we of course have Blazor. Blazor's component model is focused on handling UI interactions from the client. Now, like I said, many modern web apps actually need to use a combination of these approaches, both server-side rendering and client-side rendering. like maybe your homepage of your app or your blog, is best handled from the server so that it loads fast and is easily indexed, while more elaborate functionality in your app needs the responsiveness of running from the client. Currently with .NET, that means you can do that, but it requires using multiple different frameworks like MVC or Razor Pages plus Blazor. In .NET 8, we're working to combine the benefits of the server and client into a single consistent model based on Blazor. You'll be able to use Blazor for all of your web UI needs. You can use Blazor components to render HTML directly from the server and also get full client-side interactivity with either Blazor Server or Blazor WebAssembly from within the same app. You can even mix the two interactive hosting models and switch which one you're using at runtime. It's full stack web UI development with .NET and Blazor. Now this work to enable full stack web UI with Blazor really breaks down into five areas of investment. The first is server-side rendering with Blazor components, then enhanced navigation and form handling, streaming rendering, the ability to add interactivity per component or per page, and the ability to choose the interactive render mode at runtime. Let's take a look at each one of these areas. Now I imagine most of you are probably already familiar with server-side rendering in one form or another, especially if you've used frameworks like Web Forms or MVC or Razor Pages. Server-side rendering means you're generating HTML from the server in response to a request. Server-side rendering with Blazor means that you're going to route the request to the right component on the server, and then that component will render HTML directly to the response. There's no WebAssembly, there's no WebSockets involved here. You're just getting plain old HTML rendered to the browser in response to requests. Now this is different than Blazor Server, which in some sense is also a server-side rendering model, but Blazor Server is a persistent, stateful, connection-based model that is used to handle UI interactions. In traditional server-side rendering, the connection only lives as long as that request, and the app is typically stateless. All right, so what does server-side rendering with Blazor look like? So let's go over here to this application. So this is a recipe app that's built entirely using Blazor. If you follow Blazor fairly closely, you may have seen this recipe app before. But what's different about this one is that this one is actually built using the public .NET 8 Preview 6 bits. You can get this code off of my GitHub repo at danroth27/best4you-recipe. So you can download this and run it today. The other demos we've done were prototypes that lived in the ASP.NET Core repo, and if you could figure out how to build the whole ASP.NET Core repo, then you could run them, but it was not for the faint of heart. This one is using all of the latest features that we shipped and are publicly available for you to use. So on the home page, we've got just a list of recipes. And then if we click on a recipe, we can see the recipe details, all the ingredients and instructions on how to make that recipe. Now, if we look at the browser dev tools to see what's going on here, let's remove all the filters. And I'm just going to refresh the home page. We can see that we've got some HTML and some CSS and some images. But do we have any WebSockets? I'm going to filter on WebSockets. No WebSockets. Do we see any WebAssembly resources being loaded? No WebAssembly. There's not even any JavaScript in this app. It's just pure vanilla server-side rendering. If we look at what's coming back for the initial request, all of the HTML is being emitted from the component on the server. Okay, what does that look like in code? Here is the actual solution for this application. This is the root app.razor component for this application. You can see this is a Blazor component, and it's rendering the root HTML tag. We've got Blazor components in here for rendering the head outlet and then setting up the Blazor router. And the Blazor router will then route requests to the corresponding Blazor components that live in the app. We have an index page. If we look up here at the top, we can see there's the route being set up for this page. And we have the recipes details page that we saw as well, also has a route. Now the magic that sets up each of these Blazor components as a just normal ASP.NET Core endpoint is in Program CS. If we scroll down here, there's this new API, app.map Razor components, where we're passing in that app type. And that's what's going and finding all the Blazor components and just setting them up with endpoint routing. So normal server-side rendering based off of Blazor components. We can do form handling as well. So if I search for like chocolate recipes and submit that, that was actually a form request. It was a GET request, and it re-rendered the page with a set of chocolate recipes. If I select one of those, there's also a form down here at the bottom of the recipes where we can submit rating reviews for each of the recipes. Like if I really like this one, like so, we submit that, and then we should see at the bottom, yep, our review was added, and then up at the top, it's also calculating like an average of the star rating reviews. So that was a form post request. And if we don't like put anything, you can see that this is a Blazor form that gets actually wired up form validation as well. So we're getting validation errors too. So let's look at what that looks like in the code. In the home page, the search form is just a vanilla form, and then down below we are binding the query string data to this Blazor component parameter, and then passing that to our recipe store to then run the query for those specific recipes. That's a GET request. In the recipe details page, we can scroll down and see here's that star rating reviews component that lives over here in this separate component library. So star rating reviews.razor, and here we can see that we've got the Blazor edit form component and the Blazor like input components that we're using to build that form. When we want to model bind the data, like the form request data that comes from that submitting that form, we have a component parameter that's attributed with supply parameter from form so that we can get that data. And then when the form successfully submits with that, and it's valid, after the validation rules have all run, then our onValidSubmit method just gets executed. And here we're just firing an event to let a parent component know, like, hey, I got a new review. What do you want to do with it? And then we clear out the model for the form so that it resets. Okay, so that's form handling with server-side rendering in Blazor. Okay, so that's pretty cool. So we can now do stateless server-side rendering with our Blazor components. Now that we're using Blazor to do server-side rendering, we can start taking advantage of Blazor to enhance the server-side rendering experience of our app. The first enhancement that I want to show you is enhanced navigation and form handling. So let's say, yeah, so normally when you do a page navigation or you submit a form post, you have to do a full page refresh to render the response that comes from that request. Blazor, however, can intercept the page navigations and the form requests and instead issue a fetch request. And when it issues that fetch request, it will still do normal server-side rendering, but when the HTML content comes back, Blazor grabs that and says, let me take care of that for you. And it updates the DOM seamlessly, just the changes that need to be made to the DOM without having to do a full page refresh. This means your navigations and form handling are smoother, they're faster, and they just feel more responsive. Let me show you what that looks like. So let's go back to the app. Now, yeah, here we go. So if I navigate around, like watch the little like reload spinner in Edge, like you can see there's a little blip like every time that I navigate. That's because every time I currently navigate, it's doing a full page refresh. This is just traditional server-side rendering right now. You may have also noticed that when I submitted one of those recipe reviews, that I lost the scroll position on the page. Because again, did a full page refresh, and so we lost the scroll position. But we can do better. To do better, let's add some Blazor enhancement. We're going to go into our app.razor component, and I'm now going to uncomment the new Blazor script, blazor.web.js. And this will light up enhanced navigation and form handling for me, as well as all the fancy new .NET 8 features that I'm going to be showing you. Okay, so let's go ahead and save that, and let's rerun. Cool. Okay, so now if you watch the little reloading spinner, you can see that it's doesn't even like do the little spin. The navigations are faster and smooth. It's a little easier to see if I bring up the browser DevTools. Like if I remove all the filters and I refresh the home page. So initially on the first page load, we load everything. right? But then if I click on a page, we see that down here, the request for that particular recipe was intercepted, and instead a fetch request was made. And then the only content that we really had to download was this that HTML and then the image for the actual recipe. We didn't have to download like the CSS style sheets for the application. We didn't re-download blazor.web.js. We only had to download what was needed, and Blazor updated the DOM seamlessly. So it's still doing server-side rendering, but your app starts to feel like what you would normally associate with a single page app or a spa-style app. The navigations are smooth, not jarring, and much more responsive. So that's enhanced navigation and form handling. Oh, I didn't show you form handling. Let's do form handling too. So if I go down here to the bottom and let's submit another recipe review, like love it, and we submit that. So now the recipe review gets added, but you notice we didn't lose the scroll position anymore. The page didn't get fully refreshed. We're just still right there in the context that we were previously. You may notice there's a little bug right here that the form doesn't get cleared out. That's a bug in .NET 8 Preview 6. It's getting fixed in Preview 7. That should work, but you know, preview is still a work in progress. All right, cool. That is enhanced navigation and form handling. All right, next enhancement is streaming rendering. So when you're doing server-side rendering, sometimes when you're rendering a page, you might need to do long-running async tasks in order to render that page. Like maybe you need to go get some data from a database, or maybe you need to make an API call. With traditional server-side rendering, the user has to wait for all those async tasks to complete before the page can be fully rendered, and then it gets sent to the browser, and then the user sees the page. So while they're waiting, they see the little loading spinner in the browser, and then boop, they see the actual update. With streaming rendering, you can do an initial render of the page while those async tasks are executing. Like you can render the layout and then put some placeholder content for where you're gonna put the data that you're actually fetching, like maybe a loading ... or whatever. So with streaming rendering, you still do the GET request, and then you get an initial batch of HTML, but maybe you're kicking off a database query, but you at least get some pixels on the screen, you let the user know that something is loading, and then when the async task completes, when the database query is done, then the component renders again, and a streaming update is sent on the same response stream. There's no WebSocket connection here. This is not Blazor server. We're just using that same connection that was set up for the request to send additional updates on the response stream, and then Blazor seamlessly updates the DOM with those updates. That's streaming rendering. Let me show you what that looks like with .NET 8. Okay, so right now the home page actually loads pretty fast. Like I can mash on the refresh button and it's very snappy. The recipes in this app aren't actually being loaded from a database. It's just like a JSON file. But let's pretend that they are. So let's go to our repository for getting the recipes, and we're gonna add a simulated database query. We're just gonna add a task.delay for 1 second. It's an async task. So this, if we now rerun the app, we should see that it takes a little longer now for that home page to render. You could probably see it there, but let me do it again. I'm gonna refresh, ready, click, 1,000, boop, and then it's done. You can see the little like progress spinning thing, like 1,000 still spinning, done. So now we've got this 1 second delay, unfortunately, on our home page. How can we make that better? Let's go to the index.razor component, and I'm just gonna add an attribute, add attribute. And the attribute I'm gonna add is stream rendering, and I'm gonna set it to enabled true. So we're turning on streaming rendering for the home page. Let's look at the logic for the home page for a second. So here it says if there are no recipes yet, then it will render loading recipes ... When we have recipes, it will loop over all the recipes and render them. Down at the bottom, when the component is initialized, we're making that async, kicking off that async task to go and get the recipes, and that's where our simulated database query is occurring. The Blazor will render the component as soon as that async task is kicked off. So we'll see that loading ... initially, hopefully, if everything's working correctly. And then when the async task completes, Blazor will re-render the component again. We'll now have the recipe data. That comes down the same response stream, a streamed update, and we should see the UI update seamlessly. Let's see. Okay, did you see it? Okay, let me get rid of some of these other tabs because we have a bunch of recipe apps that open now. So I'm just gonna refresh the home page, watch it. So refresh, there's that loading recipes, ... And then a second later, we get the streamed update. If you had multiple async tasks that you were doing, then you could get multiple streamed updates that would come to the page. So that's streaming rendering with Blazor and .NET 8. You get pixels on the screen faster, so your app again feels more responsive. Still doing server-side rendering. We haven't done anything client-side yet. We're just making our app feel like a client-side based application by leveraging some progressive enhancements. Okay, now it's time to actually add some client-side interactivity. In addition to server-rendered HTML, we also want to be able to use the client capabilities of the web platform. With Blazor, we have two ways of enabling client interactivity. We have Blazor Server and Blazor WebAssembly. Whether you choose to use Blazor Server or Blazor WebAssembly for your app depends on a variety of different factors, like load time performance requirements, your UI latency requirements. Like load time, the Blazor WebAssembly, it's going to be a little bigger to download because you have to download the runtime, so the load time's a little slower. Blazor Server will load faster. UI latency, Blazor Server does all the UI interactions over the network, so there's only so much you can do about the speed of light, as in nothing. You can't do anything about the speed of light. So there's going to be a little bit of delay when you click the button before the component renders and the response comes back. Blazor WebAssembly, you're running code locally on the device, so you can do low latency stuff. Scalability concerns, Blazor Server is utilizing your server resources to drive the user interface of your app. So you're paying with server resources to do that. With Blazor WebAssembly, you're pushing that load to the client. So trade-offs, right? Engineering trade-offs. Today, choosing between those two models is typically an upfront choice. Like you decide, I'm going to be a Blazor Server developer. I'm building a Blazor Server app. I'm going to pick the Blazor Server template, and that's what I'm going with. Or I'm going to build a Blazor WebAssembly app. That's what I'm going with for this particular application. And you typically are today choosing that for the entire application. In .NET 8, we want to enable you to add client-side interactivity on a per page or per component basis. So when you have a component or page that needs interactivity, you can choose to just sprinkle a little interactivity on that page. And now you have a little island of Blazor Server or Blazor WebAssembly in what is otherwise potentially still a server-side render app. Or if you want to enable it for the whole application, you can still do that too. Set any circuits that get set up, like any server-side state for Blazor Server, or downloading the Blazor WebAssembly runtime, that only happens on the pages where you're actually using those features. If you're not on a page that's using those features, then you're not paying for them. There's no overhead. Let's see what this looks like. Okay, let me go back to the recipe app. Now this recipe app has a third page, which is this submit recipe page. It's got a recipe editor where I can submit new recipes to the application. Like maybe I want to add some chocolate chip cookies. And I want this UI to be a more sophisticated user interface. Like it has this little picture picker where I want to be able to pick an image for my recipe. I think I have chocolate chip cookies, there we are. And we'll add that. Right now, it doesn't preview the image for me. It just displays the file name, which is kind of lame. And then it has this ingredients list editor where I can add ingredients like 300 grams of flour. Currently, if I click this button, nothing happens. There's nothing handling the button click event. And that's because this page hasn't been set up for interactivity yet. It's still just doing vanilla server-side rendering. The only real interactivity you can do with server-side rendering is like doing form posts and the like. How can I make this page interactive? Well, let's go and do that. So if we go back to the code, let's find that submit recipe page. This is it. All the logic I've factored into this recipe editor component. We can go to definition to see what that looks like. So here's all the form fields for the recipe editor. We've got that image picker here. We've got a little bit of like, I think there's some JavaScript interop code that's like generating a data URL for the image. And we got button click handlers for this ingredient list editor component. So fancy stuff. And I want this component to be interactive. How do I do that? Well, we can just do that by adding a render mode, an interactive render mode. And the one I'm going to start with is Blazor Server. We're going to use Blazor Server first for this render mode. Would be correct? Great. Okay, so now just this component in the app should be interactive using Blazor Server. Let's see if that works. We start the application. Let's go back to the recipe page, cookies, and let's add an image, chocolate chip cookies. And aha, we're getting a little preview of our chocolate chip cookies now. When I add some ingredients, that's all working too. I can add some eggs. I can drag and drop stuff and switch between imperial and metric units, and we get all the normal form client-side validation logic now running because we've made this just this one component on this one page interactive using Blazor Server. Now you could also, and this is doing specifying a render mode for a component instance. If you want to, you can just declare that this entire page should be using Blazor server. You can do that using the render mode server attribute. That's basically saying wherever this component gets used all the time, it should be Blazor server. And that's convenient, particularly when you have pages. We recommend using this sparingly. In general, Blazor components are all about reuse, like they're components, right? You're supposed to be able to reuse them in a variety of places. You generally don't want to tie your components to a particular render mode or hosting model. You want them to be able to be used with WebAssembly or server or Blazor hybrid or anywhere you want. So generally, we would recommend not baking in the attribute to say this is only a Blazor server component, but in some cases that's needed, and so that is also available. I like the other models in this case, so I'm going to switch it back like that. Okay. What about Blazor? Oh, I didn't show one important thing. So let's see what's happening in the network tab. So if we go back to the browser DevTools, and let me make sure I've removed all filters. I'm going to refresh the home page. Okay. Now on the home page, do we have any WebSockets? I'm going to filter to WebSockets. No WebSockets yet. If I go to the submit recipe page, aha. Now we see the Blazor server WebSocket connection being set up. We've got a circuit. The page is interactive. When I navigate away from this page and go to the home page, it's gone. So you've freed up that circuit. So the scale characteristics of your app are much better. Your Blazor server circuits can be much shorter lived. All right, now what about WebAssembly? How do we do the WebAssembly render mode? Well, we can just change this render mode to WebAssembly. Let's do that. And we'll go ahead and run this app. Okay, so it should still work if I try to upload an image like this. That can work. Yep, so this page is still interactive. But now if we go look at what's happening on the network tab, and for this I need to make sure I don't have any Blazor WebAssembly cache anywhere. Let's clear all the caches. We're not cheating. There's nothing cheating going on here. And let's look at the network tab on the home page. Let's look at everything. Okay, so on the home page, do we have, what just happened today? Click on something. Okay, great. I don't know what I just clicked on. Okay, on the home page, do we have any WebSockets? No WebSockets. Do we have any WebAssembly yet? No WebAssembly yet. But if I browse to the submit recipe page, now I see that dotnet.native.wasm. This used to be called dotnet.wasm. I don't know why it got renamed in .NET 8, but reasons that the .NET runtime team I'm sure have good reasons for. And then we can see all of the assemblies, the code for the Blazor WebAssembly app being downloaded to the browser. This will then get cached. So if you have any other pages or components elsewhere in the app that need Blazor WebAssembly, it'll already be there and they can just go ahead and use it. So the WebAssembly runtime is only downloaded and cached when you have a page that's using that particular render mode. I know right now this looks like it's a little big, like it's like, wow, 20 megabytes, what's up with that, Dan? This is development. We don't do any of the optimizations to like trim the app and compress things and all that fancy stuff to make the app as small and tight as possible. When you publish this app, all that will happen. And like the overhead for Blazor WebAssembly is roughly about a meg or so. So this goes way down once the trimmer has its chance and the compression logic is run. All right, cool. So that's in adding client-side interactivity. All right, so that's pretty neat. Like you can, per page, per component basis, decide if you want to use Blazor WebAssembly, Blazor server. If you change your mind, you just switch the render mode. You don't have to like restructure the app extensively in order to be able to do that. But sometimes you might actually want to delay the decision of which render mode you want to use until runtime. For example, maybe you prefer to use Blazor WebAssembly if the .NET runtime, the WebAssembly runtime is available. But you want to avoid the user being impacted by the load time of downloading and loading that runtime. So what you might do is you might actually start off a user using Blazor server, which loads really quick and still is interactive, and then download the .NET WebAssembly runtime in the background and cache it. And then when the user comes back to that page or to that app, the app can see, oh, look, the runtime's already here. Let me just go ahead and use that. And it can switch at runtime to using Blazor WebAssembly instead. That way you kind of get the best of both worlds. You get the fast load of Blazor server, but you get the true client-side characteristics of Blazor WebAssembly. So you a user comes to your page. Initially, you set up that WebSocket, but you sneak down the .NET runtime in the background, and then maybe they refresh the page. The app now looks and says, oh, wow, there's a runtime here already. I'm just going to go ahead and use that. You've now offloaded that load from your server to the client, and everybody's happy. What would that look like? OK, so if we go back to the app, what I would love to do is change this render mode to auto, the auto render mode. That would be pretty cool. It's not yet implemented in .NET 8, unfortunately. So I can't actually show you with the .NET 8 preview 6 bits. The PR actually just went out, like it's going in for the next, I believe, for the next .NET 8 preview release. But I can't show you with this version of the app. So for this part of the demo, I'm actually going to switch back to a earlier prototype implementation of these features that lives in the ASP.NET Core repo. This code's a little bit older, a little staler from what we're actually shipping in .NET 8. But the concepts are still the same. So here's that recipe editor component, and here I'm using the attribute model to say I would like this component to use the auto rendering mode. Let's see what this looks like. And I think I need to stop the other app because I think they both use the same port. There we go. All right, so we should see our recipe app. There it is. Okay, our streaming rendering was working. Go to our submit recipe page. No, well, hold on. Let's start at the home page. Let's do the whole thing. So let's clear all the caches so we make sure we don't have any cheating here going on. Empty refresh cache. Okay, so on the home page, do we see any WebSocket connections? No. Do we see any WebAssembly? No. Okay, so but if we go to the submit recipe page, aha, so now we've got a Blazor server WebSocket connection set up. But if we look at for WebAssembly, we can see, we've also downloaded the .NET WebAssembly runtime in the background. Now, which one are we actually using? If we look at the dev console, we should see right here that it's saying that it's running over a WebSocket connection. So right now, we're using Blazor server. But let's say the user browses away from this page and comes back, or we're just going to simulate that by refreshing the page. And now you can see it has switched to executing using WebAssembly at runtime. So you have made a runtime decision, a policy decision on which render mode you want to use, and you get the best of both Blazor WebAssembly and Blazor Server all at once. So that's the auto render mode. This is just an example of one runtime policy that you might have. We actually plan to make this extensible so that you can have others. Like maybe you like using Blazor WebAssembly, but you don't want to use Blazor WebAssembly if the client has a very low-powered device. Like you don't want to burden a low-powered device with running all that client-side code. So you'll take the load off of them by running it from the server. That's another policy that we hope to enable with this model. So you can choose when you use server or WebAssembly. Cool. So how can you get started using all these cool .NET 8 features? So in .NET 8, we are introducing a new Blazor template, the Blazor web app template that sets everything up for you, the server-side rendering, interactive rendering models, so you get the best of Blazor Server and Blazor WebAssembly in one template. It has all of the progressive enhancements enabled as well, and it has options for enabling the different interactive rendering modes, like if you want to use Blazor Server as part of your app, you can check a checkbox and say, yep, I want to please enable that feature. Or you want WebAssembly, you can have both. Or you can say, I'm not using WebAssembly at all, just turn that off. I don't need any of that stuff. These are all things that will be enabled by this new template. And we're hoping that this will become the one-stop shop for all your future Blazor web applications. Just create a Blazor web app and away you go. Let me show you what it looks like. So let's go back to, actually, I'm just going to open up a new Visual Studio instance. And let's create a new project. And yeah, so these are all the Blazor templates. And the one I want you to draw your attention to is this new Blazor web app template, okay? That's the one we're going to create. We'll do next. That shows up if you install the .NET 8 preview. And that seems like a fine name for our Blazor web app. And then here, notice I've got this option checked that I want to use interactive server components. So this will set up the template so that we can use Blazor Server for wherever we want in the application. We don't yet have an option on the template for enabling Blazor WebAssembly. You can do it manually, and we have samples on how to do that. There's some rough edges still that we're working through. and we will add the Blazor WebAssembly option in an upcoming .NET 8 preview. You can do it today, it's just requires some manual steps. Okay, so let's go ahead and create this and see what we get. Let's see what a Blazor web app looks like in .NET 8. Let's start here in Program CS. So the first thing you need to do is add the services for using Blazor components. And then because I checked that option, it's also adding the services that enable support for Blazor server interactivity. And then down below, we map the Blazor components pointing at the root component for our app so it knows where to go find all the routable components. That's what's going to go and set up all the set up endpoint routing for each of our Blazor components so server-side rendering will work. If we look at app.razor, this is the root component for the app. Again, it has the root HTML tag. It's set up with the head outlet, and we're setting up the Blazor router. It's also set up with the new blazor.web.js script. So this is kind of the root of your application, and then each of your pages are over here. So in index.razor, this looks like every index.razor you've probably ever seen in a Blazor app. It's just some fixed content on the page. In this template, this page will be server-side rendered. Doesn't need interactivity. There's no buttons, nothing there on here. So it's just going to render from the server and be done. Well, on the counter component, we have the normal counter component code. But at the top, we are saying, you know what? This counter component, I want to be interactive, and I want to use Blazor server for that. So this is an interactive component. And then the show data page, this is the weather forecast page. And it's going to render all the weather forecasts into a table of weather forecasts. It has a little, again, a simulated API call, if you will, to go get the weather forecast data. So it has an async task that will happen when the component is initialized, and it's set up to do streaming rendering. So you can see all the new .NET 8 goodies. If we run this, you can tell we're using .NET 8 because we get that little security pop-up. That security pop-up happens because HTTP3 is now enabled by default and requires certain TLS features that require that acknowledgement from Windows for some reason. But anyway, here's the home page. This is just a server-side rendered page. You know, all the content is right there. If we look at the source, on the counter does work. It's an interactive component. It is the only interactive component in this application. This is the only page where a circuit needs to be set up. And then on the fetch data page, you see the loading ... and then the weather forecast table renders. So we're getting streaming rendering as well. So this is how you can quickly get started with playing around with the new full stack web UI features in Blazor in .NET 8. Yeah, for the WebAssembly stuff, there's a sample that you can go look at, but as future preview, there'll just be another checkbox where we'll set up the whole template for you so you can also do WebAssembly. One little note, we were previously trying to do a single project model for both Blazor Server and Blazor WebAssembly. Like Blazor WebAssembly is kind of interesting, right? Because it's actually a separate process. Like it's a separate build output from your Blazor app. You have code that's going to run on the server, and then you have code that's going to run in the browser on the client. And you probably don't want those to be exactly the same thing. Like there's server-side code that just won't even work in the browser, and you want the code that goes to the browser to be as small as possible. So you want to carefully manage what code you put in there. We had hoped to have a single project model where we used multi-targeting to build it for both the server and the browser in one project. That turned out to be pretty complicated because of all the concerns with building for the browser. Like it was really easy to have a lot of code that you didn't want to go to the browser end up in the browser. So for .NET 8, the plan is still that you will, if you set up the WebAssembly render mode, you will still need multiple projects. You will still have a client project and a server project. And that makes it really clear what's actually being built for the client and what code will be shipped down to the browser. So if you've been watching earlier demos, that's a change, a slight change in direction. I still hope that we'll get to that single project model, honestly, but not for .NET 8. All right, what if you have existing Blazor apps? How do you upgrade them to .NET 8? Well, the good news is it's trivial. You just retarget your app to .NET 8, update any NuGet packages to the .NET 8 versions, and they will just work. You don't have to change any code. Your existing Blazor server and Blazor WebAssembly apps still supported, still will be completely functional. You then have the option to further upgrade that app to use the new .NET 8 patterns. Like if you want to switch from Blazor server.js to Blazor web.js and enable server-side rendering and streaming rendering and those features, in addition to the Blazor server stuff, then you can do that too, and we will provide guidance and docs on how you do that. Let me demonstrate real fast. So let me go back to Visual Studio. let's create a new project. I'm going to create a Blazor server project for this demo. Now in .NET 8, because the Blazor web app template actually can do everything that a Blazor server app can do, we've removed the .NET 8 version of the Blazor server template. You should just create a Blazor web app. If you're a Blazor server developer, just create a Blazor web app and it'll have what you had before and more. But for this demo, I actually want to start with a .NET 7 Blazor server application, just to prove a point. So there we go. So here's a .NET 7 Blazor server app. You can see that it's targeting .NET 7 in its project file. We run it, it should work and function as any other Blazor server app would. Yep, all functional. Okay, and what do I need to do to change this to .NET 8? I just do that, like target it to .NET 8. And now this is a .NET 8 Blazor server app. It's just that simple. If I rerun this again, well, I guess, and well, you can tell it's a .NET 8 app because we get that security prompt saying it's now using HTTP3. So let's go ahead and allow that. And then it should run again. I think it ran again. Did it run again? I'm just gonna make a little code change just because I want to make sure that we are actually, hello from .NET 8. Save, and let's run that. I think sometimes it just doesn't pop up. Yeah, okay. So it was running. It's just that Visual Studio for some reason didn't bring the browser to the forefront. So we're running on .NET 8 now. All we had to do was change the TFM. If you have packages, make sure you update your packages to the .NET 8 versions as well. If you want to then take this Blazor server app and turn it into the new full stack web UI model, we'll have docs and samples on how to do that. I have one on my GitHub repo, Dan Roth 27, Net 8 Blazor server. This repo here, if you want to see that this guy right here, it starts with a .NET 7 Blazor server app and then has commits that walks through how you upgrade it to .NET 8 if you want to use all the new bells and whistles. And there's some steps here outlining on how to do that. Okay, it should be straightforward upgrade. What if you're using MVC or Razor Pages or something, you're not using Blazor? What does this all mean to you? Well, we have been progressively adding more and more features that enable you to integrate Blazor into existing MVC and Razor Pages apps, and really any kind of app. Like if you have a React application or an Angular application, you can add Blazor to that. Even prior to .NET 8, we have been shipping a component tag helper that you can use in an MVC view or a Razor page that allows you to render a Blazor component as part of that page. That's already supported today. You can do that with .NET 7. New in .NET 8, we're adding a Razor component result, which you can return from a minimal API, or you can even return it from a MVC controller action and say, instead of like rendering an MVC view, I'd like to render a Blazor component. And that's now supported as well in .NET 8. For other style apps, you can always take a Blazor component and turn it into an HTML custom element and embed it in any web application that you want. Like you can put it into a React app. You can technically even put it into a web forms app. I think we recently published a blog post that described a migration strategy for web forms applications where you can kind of whittle away at the UI controls by embedding Blazor-based custom elements into the web forms application, which is a pretty cool concept. I'll show you the Razor component result real quick. Let's go to 10, 40, plenty of time. Okay, great. All right, so let me, what did I want to do? I wanted to show, we're doing Razor component results. So I wanted to do open, no, recent projects, this guy. Okay, so this is a Blazor application, but it's also got a couple of other things in it. So if we look in Program CS, down here at the bottom, I've got a minimal API effectively, or just mapping a route, and I'm mapping it to this /route, like literally route, and all it does is return a Razor component result. And it's rendering the home component. I happen to name the index component in this app home. I think that's a little more natural, honestly, but whatever. It's basically the index.razor file. And I changed the home component to have a component parameter. Like here you can see it takes a string message and then renders it in the heading. And so when I'm rendering that Razor component result, you can see that you can also pass in parameters that you want to pass to that component. Also, I've got an MVC controller aptly named MVC controller, and it has an index action, and this is also returning a Blazor component result. Again, the home component, and this time passing a different message, saying hello from MVC instead of hello from, what did I do in the other one? Hello from route? Yeah, hello from route. Okay, so if we run this, okay, so this is the normal Blazor app. But if I browse, and this is the home component that's rendering, and it's just doing its default text, hello world. But if I browse to /route, we can see that the home component is now rendering, and it's saying hello from route. We don't get the layout. Why don't we get the layout? That's because layouts in Blazor are applied usually using the Blazor router. Like the Blazor router sets up a default layout for all of your pages. I'm not actually using the Blazor router here, so I don't get that. I could add the layout to the component using the @layout directive. That would work as well. But this is mostly just about proving the point that I can render a Blazor component from anywhere I want. If I browse to /MVC/index, then now it says hello from MVC. So I'm hitting an MVC controller, which is now returning a Blazor component as well. So that's how you can use Blazor component result to render Blazor components in a variety of places. Now, one of the happy side effects, or a convenient side effect of the work that we have done to enable server-side rendering with Blazor is that you can now in .NET 8 render Blazor components completely outside the context of an HTTP request and completely outside of the ASP.NET Core environment. You can take a Blazor component and render it to HTML directly as a string or just as a stream, and then do whatever you want with it. This is useful for scenarios where you want to just generate some HTML, like for maybe you're trying to send out some emails or trying to generate some HTML fragments for something. It also would be useful for static site generation. We plan to, we have in our roadmap to add static site generation support to Blazor. What that means is instead of waiting for the request to render the component, what if we just rendered the components at build time, generated a bunch of static files that you can then put on a CDN and distribute everywhere? That would be super fast. That's something we also expect to add to Blazor in the future, not for .NET 8, but this work is laying the groundwork for that capability as well. So let me show you what that looks like. So let's go to this project. So Razor HTML rendering. This is just a console app. This is not an ASP.NET Core app. We're not setting up the ASP.NET Core host. There's no HTTP requests happening here. We have a component, this myComponent.razor, that's just rendering the current time. And we're using this new API from .NET 8, the HTML renderer, to take a component and just render it to a string or to a stream. Here we're calling render component async. That's how we do that. And we pass in the type of the component we want to render. Again, you can pass in component parameters that you want to feed into that component so that they get used when the component renders. And then here I'm rendering it to a string, but you could also render it to a file, like to a file stream. That works as well. I'm then taking that HTML output and just writing it to the console. The one little tricky bit here is that components need to be rendered in the context of a component dispatcher. That's what this dispatcher property is on the HTML renderer. So you first got to call invoke async, and then within that context, you do all your render component async calls. That's the only sort of tricky bit about this. Otherwise, it's pretty straightforward. So if we run this is just a console app, and you can see up above, we took a component, rendered some HTML from it, no requests, no ASP.NET Core. This is a way that you could start to use Blazor components for templating of any HTML content that you want. So that's generating static HTML content with Blazor components. What about WebAssembly? We continue to invest in our .NET WebAssembly capabilities. The .NET WebAssembly runtime is getting a whole bunch of new features and improvements in .NET 8. If you're using ahead of time compilation, we are now turning on SIMD and exception handling support using the extension WebAssembly specs by default, which significantly improves the runtime performance of your code. We are working to preview multi-threading support for Blazor WebAssembly in .NET 8. The PR is out for that right now. It's looking like that might still stay in preview for .NET 8, but it will be available. You will be able to create a Blazor app, enable multi-threading, and use it. It just might not be fully stable yet because there's complexities with doing multi-threading inside of a browser, but it's coming. We've done a whole bunch of work to improve hot reload support when running .NET code on WebAssembly. The .NET WebAssembly runtime now has full parity with the supported set of edit types that Core CLR supports. So whatever edits you could do with like a Blazor server app or an MVC app, you should now be able to do those same edit types in a Blazor WebAssembly app, which is pretty great. A feature that I'm really excited about is JIT-terpreter. Blazor WebAssembly apps today, by default, will run on an interpreter-based runtime. So it's taking your .NET IL code and interpreting it in order to execute it. There wasn't really a great way to do JIT, like a full JIT at least, on WebAssembly. So we're doing an interpreter-based approach instead, and that impacts runtime performance. Like it's not going to be as fast as like a full JIT server-based runtime. But in .NET 8, we have found a way to add at least limited JIT support. The interpreter now has an additional tier where it will take chunks of your .NET code at runtime, JIT out or generate out WebAssembly modules, small WebAssembly modules that can then be loaded synchronously at runtime and optimize code paths in your Blazor WebAssembly app. And this is resulting in some pretty significant runtime performance improvements, like 20% faster UI rendering, 2x faster adjacent deserialization times. So you should see your Blazor WebAssembly apps in .NET 8 just get a perf boost. You don't have to do anything. It's just on by default. So that's the new JIT-terpreter, limited JIT support. Blazor WebAssembly apps in .NET 8 are now CSP compliant. So if you need to have enable the content security policy based loading restrictions on your app, you can now do that with your Blazor WebAssembly apps. And we're also introducing a new packaging format for Blazor WebAssembly apps called WebCIL that's more web-friendly. .NET assemblies are Windows portable executable files, like Windows PE files. In some restrictive environments, they take issue with that. Like you're just going to download some DLLs across the internet. Like they run in the Blazor, in the browser security sandbox. So you can't do Blazor can't do anything with those PE files that you couldn't already just do with JavaScript. They're still in that sandbox, but some security software will see the DLL and be like, nope, and it'll just block the application. We've received some reports of that. So in .NET 8, what we're doing is we're stripping off all the Windows PE specific stuff from the .NET assemblies when we package your Blazor WebAssembly app, and then repackaging that content as a WebAssembly file, as a WASM file, and using that instead. And that should hopefully avoid any of these issues where people deploy into like a really restrictive environment and then see their Blazor WebAssembly app get blocked. So that's the new WebCIL packaging in .NET 8. Again, on by default, don't need to do anything. Just redeploy your app and you'll get the new friendly packaging. In the Blazor framework itself, there's also a bunch of new features. So QuickGrid, we previewed QuickGrid with .NET 7. QuickGrid is a fast and functional data grid component for Blazor that comes from the Blazor team. In .NET 8, we're going to ship a stable version of QuickGrid that you can just use to display your data. Sections support is coming in .NET 8. Sections is a way that you can create an outlet for some content on one component that can then gets filled in by another component. If you've used MVC or Razor Pages before, it's very similar to the section support in like views and pages, except now done with Blazor and Blazor components. With client-side routing, we can now route to a specific named element on a page, so you can like navigate to a particular spot on the UI. For Blazor server apps, we're adding new APIs so that you can monitor your circuit activity and in the future handle idle circuits. Like if you have a circuit that's just someone opened up the browser and just sat there and then went to lunch and isn't using those server resources, you might decide, you know what, you're not using this, I'm gonna shut this down so that you free up those server resources. And we're also doing a bunch of authentication improvements in .NET 8 across the board, not just for Blazor, but they will enable you to completely build and customize your identity UI using the Blazor programming model. A few words about that. We've heard a lot of feedback from our ASP.NET Core users that they'd like to see a better story for authentication, particularly for single page apps, for SPA apps. The problems with authentication in SPA apps today are, well, for one thing, today we use OpenID Connect to set up authentication for these apps. And we use a third-party component to do that called Duende Identity Server. Duende Identity Server is a great component, awesome project. The folks that run it really know what they're doing. but it now has a commercial license. And honestly, for a lot of apps, having a full OIDC server is a bit overkill. Like you don't really need it. That was one problem. The other problem is that the UI that we give you, the default UI at least for ASP.NET Core Identity, was built with Razor pages. But if you're building a React app, that's a little weird. Or you're building a Blazor app, like I want my identity UI to be in Blazor, or I want it to be in React. So what we're doing in .NET 8 is we're removing Duende identity server from our templates. You can still use them, like they have awesome templates of their own that you can leverage to set them up. And we recommend doing that if you need full IDC compliance. But instead, we're introducing our own set of client-friendly endpoints for identity management that let you get like bearer tokens or get set up cookies and query the identity data stores to get information about the users. You can then use those endpoints to build out your own identity UI, and we'll provide samples and content for identity UI for Blazor, and then I think we're planning to do Angular and React. So that's coming in .NET 8. I want to show you two of the other Blazor enhancements really quick. Let's go over here. Let's look at, actually, let's look at QuickGrid real fast if you haven't seen it before. So the easiest way to see QuickGrid is go to the QuickGrid demo site. So that's AKMS Blazor/QuickGrid. Okay, so this is a Blazor app, and we can see an example of QuickGrid here. QuickGrid is a fast, lightweight, and functional data grid component. It supports pagination, it supports sorting, you can do filtering, search for all the Canadian metals and so forth. It also supports data virtualization. So this is a QuickGrid example that's loading 22,000 rows of medicinal data sets. As I scroll, you can see that the data is being loaded as I scroll, as opposed to sucking in all 22,000 rows into memory at once. You can completely style it. Yeah, it's a very designed to be fast and very functional component. It doesn't have like every single data grid feature. Like if you're really looking for every bell and whistle on your data grid, then we definitely recommend go and check out the commercial data grid components or some of the community ones from the component vendors or the various open source projects. But for many scenarios, it's more than adequate. So that's data grid. We'll have a stable version in .NET 8 that you can just add to your existing apps. And then let's look at sections. Blazor sections. Okay, so this is a Blazor application, and sections allow you to define outlets for content. So here in my, my layout, I've defined a section outlet using the new section outlet component. And you just give it a name. So I'm calling this one top row. And that's because it's in that sort of top row gray bar that's in every Blazor template. And then in the pages, I can then provide section content for that outlet. So on the home page, we've got the section content, again, same name. And here I'm just providing some static text. So we're gonna stick home up in the top. In the counter page, we've got section content. And here we're adding another button that is like an additional counter button. So we got two counter buttons now. And then on fetch data, we have a section content that is just rendering the weather for, I think it's for the weather for tomorrow. Okay, so if we run this. Okay, so on the home page, see up here, it says home up in the corner. There's our section content being filled in. On the counter page, we've got a counter button up top and a counter button down below. They both work, so we got two counters. On fetch data, you can see that the weather is supposed to be chilly, yep, tomorrow, and it shows up in the section outlet as well. So that's sections, very much like sections in MVC or Razor pages, if you're familiar with that, except now you're using components in order to set that up. All right, cool. So here's a summary of all the stuff we've talked about, all the things that are coming to Blazor in .NET 8. Full stack web UI with all the new capabilities, server-side rendering, streaming rendering, enhanced navigation form handling, interactivity, and deciding the interactive render mode at runtime. We have a bunch of framework enhancements that we're adding. You can generate static HTML using Blazor components, QuickGrid sections, routing to named elements, and then a whole bunch of WebAssembly runtime improvements as well, including preview multi-threading support, most likely. We'll see. Maybe we get it stable. I don't know. Probably preview. JIT interpreter support, hot reload improvements, WebCL packaging, and so on. If you're a backend developer, There's lots of great stuff in ASP.NET Core, in .NET 8 as well. Like for server side development, we are on a journey now to enable full native AOT for ASP.NET Core apps. In .NET 8, we're targeting minimal APIs, where you can take your code and completely pre-compile it for the architecture that you're targeting, get much better memory characteristics, smaller deployment sizes, much faster startup times. New middleware for request timeouts and short circuits. We're adding a bunch of metrics so you get much better observability for your ASP.NET Core apps. Kestrel in .NET 8 now supports name pipes, so it has a completely new transport. We already talked about how HTTP3 is now enabled by default. Whole new authentication story in .NET 8, the new identity endpoints, and then also an API development experience in .NET 8 that's vastly improved, lots of great productivity tooling and features that you can use to build out your APIs. So front end, back end, using .NET, we've got you covered. That's what I had today. I hope you enjoyed learning about this stuff. If you haven't, go install .NET 7. That's the supported, production-ready version of .NET that you can build your Blazor apps with right now. And if you would, please try out the .NET 8 previews. Give these features a spin. There will be rough edges still. There's things that we're still working on. We're pushing out the features as fast as we can implement them. But your feedback helps us make sure that they're meeting your requirements, meeting your scenarios, and making Blazor as good as it can possibly be. And with that, I'm happy to stick around and answer some questions. Thanks, everyone. Any questions? I got some time. Yeah, we have. So it's up to you. Like, this is a policy that you get to define in your app. Like, a lower power device maybe is like an older phone, right? Like, or an old tablet where you're like, I don't know if it's got the CPU, the juice in order to run my application, and I'm going to offload that work to the server. So how you would detect that? Like, you'd have to use the HTTP request, like whatever headers you get back from that device to know what kind of type of device it is. But it's up to you to write that policy. We don't plan to provide that as like an out-of-the-box thing. That's okay. Do we have? We don't really have official guidance on that. I can say that, I mean, we have received feedback that on lower end devices, Blazor WebAssembly can drag. I don't think we have great numbers yet, like, okay, you need at least this level of device in order to have a really good experience on the client. We probably should. And what would be better is if we just improve the Blazor WebAssembly experience so that even on low power devices, it still works well. That's work that we have on our backlog to investigate as well. Hopefully, JITterpreter, like that will help because it speeds up the runtime performance. Some of it is just like the browser itself, like how long it takes the mobile browser that you're using to like compile the WebAssembly code and get it up and loaded and running. Sometimes it's, the platform itself is just a little sluggish compared to more modern devices. Something we should do a better job of providing guidance on. Yeah. Yeah, so there's a blog post that we just put out about this. It's the System Web Adapters 1.2 blog post. The trick that you can do is that you can take a Blazor component and you can turn it into an HTML custom element. When it's an HTML custom element, you can render that anywhere. Like you should just think of it as like another HTML element that the browser now knows what to do with. So you could take like a Blazor WebAssembly based Blazor custom element and just embed it directly into a web forms app. That would work. Another pattern that you can do is you can put a Blazor server app in front of your web forms app. This is what we call the incremental migration pattern, where you have an existing ASP.NET app. Let's say you want to upgrade to the latest .NET platform. You put an ASP.NET Core app in front, and then use our reverse proxy, use YARP, so that requests go to the ASP.NET Core app first, but if they don't get handled by the ASP.NET Core app, then they get directed to the ASP.NET app. So it looks like one app, but you can start slicing off pages. What's that? Yeah, gets a first shot at the request. So that way you can slice off pages of your app and migrate them to, say, MVC or whatever you want, a page at a time. Because a lot of times people have these apps that they're still developing, and it becomes this race. Like I'm trying to port it to ASP.NET Core, but I'm still developing the app, and so it's always a moving target. The incremental approach allows you to keep developing the ASP.NET net app while you're upgrading. If you do that, you could put a Blazor server hub in the ASP.NET Core app and have Blazor server components that get embedded as custom elements in the web forms app, and even be using the Blazor server model there to like whittle away like a control or a component at a time. That's a pattern that we have now guidance and samples on how you could set up. Repeat the question. Yes, so the question was, I mentioned before about embedding Blazor components into a web forms app. Is that something you can do? And the answer is yes, by leveraging the custom element support in Blazor. Thank you. Any other questions? You're excited? Yes, I'm excited as well. I think it's going to be pretty epic. One model to build all of your web UI components, server, client, interactive or not, whatever you want to do, you'll be able to do this with the Blazor programming model. I think it's going to enable some pretty compelling experiences. Anything else? I will, of course, be here later today at the Ask the Experts table. So if you want to chat about your latest Blazor war stories and what's going well, what's going wrong, feel free to come find me. I'm happy to chat. Love to hear your feedback on things that you think maybe we should be doing better in Blazor. That's all cool. And I'll also be here tomorrow at the table, the experts table event as well. So I'll be around if you didn't get your question answered today or you think of something after the session. But thank you everyone for being here. I hope you enjoy this and try out .NET 8. Thanks, folks.